Hi, welcome back to another tutorial video. This time we will learn to generate the line that represents the blue surface or the blue region of a diffusion flame. So if you can see on the screen right now, this is a typical diffusion flame where the orange region is called the sooty region and the blue region is called the flame front, and it's also often called the flame sheet. There is a parameter that can represent this blue region, which is called the stoichiometric mixture fraction. You can refer to combustion textbooks for the concept and formulation of stoichiometric mixture fraction. In CFD, you can actually replicate this blue region or the blue surface using post-processing techniques. In this tutorial, we are using OpenFOAM as our CFD program. So let's get into our CFD simulation folder. Here we are already at the path where the case folder is located. Now let's view the results in ParaView using the parafoam command. Let's check these two boxes again and then apply. This time around we will look at the Z parameter, but first we will have to refresh, uncheck the box for the volume fields and recheck it. Now we have all the simulation results available. Now we want to select the Z or the Z for mixture fraction, and then we would generate a contour. We will specify the contour by Z, and then we put a value for the isoline. One of the simplest way to do it is by going back to our flamelet table. So here I have already navigated to the tutorial lookup table. If we view the folder logs and the file called log enthalpy defect _0, actually we have to change that to head. We don't want to look at the whole thing, so we're just going to extract several lines from the top of the file. So what I did was specify 100 lines. So the first 100 lines will be shown to you. If you can see on the top here, the stoichiometric mixture fraction is 0.25. If you go back to your ParaView, you can specify 0.25 over here, and then you hit apply. You will see a thin line generated. What you can do to make it more visible is you can change the coloring. First change the type of color to solid color, and then we change it to blue. Blue is always nice because when we want to compare with the actual flame, it will be comparable. Okay, so the next step that you can do is to rotate. So I just typed in 90, means 90 degrees counterclockwise, and then I just hit tab. Since the orientation of the flame simulation is in the horizontal side, we are going to make it appear in the vertical manner. And then you can change the background color and make it black. Now this is the ISO line that represents the blue flame. Next we should save this picture, save screenshot, hit OK, and then give it a name. For example, blue flame 1. This will be automatically saved in the case folder, and then you can edit it using Pinta image editor. This is the one that I recommended to be used in Linux. So let's open that figure. We'll go back to OpenFOAM, run flamelet tutorials. Yeah, tutorial. Case 1. There you go. Now we have this Isoline created for us over here. If we want to know what the range of the height is, then we can always go back to our paraview and show axis. So that ranges from 0 to 20 millimeter height above the burner, more or less. So if we go back to our Pinta editor, we know that the bottom here is 0 and the top here is slightly above 20 millimeters. Now we will just take a snip of this picture, cut it, and then you're gonna paste it in another window. Go to the actual image. Now the actual image comes from the study of How 2012. So the one that we are going to compare the image with is this one over here. See, the flame inlet conditions are similar to what we have simulated. 30% oxygen concentration and 30% methane concentration, as well as 5% ethylene concentration. We are going to crop this image. If you notice, the entire flame height is around 7 centimeters. If we go back to the smaller image over here, we can see that the top here, it is around 70 millimeters or 7 cm. I'm just going to print screen and then paste it in a new window and cut it and paste it into a new window. Of course, the image looks different in size, but we are going to resize these two images. This image is just too small, right? It's not proportionate to the simulated Isoline. This one from top to bottom is 7 centimeters or 70 millimeters. But this one over here is from 0 to around 20, 22 or 23. Now what we are going to do is we are going to resize this image. So we can say that the height of the blue Isoline here is actually reasonably close to the height of the blue flame. If we look at the reference paper, by sheer observation, this flame right here that represents this one is actually featuring a blue flame that has a height of around 10 millimeters or 1 centimeter. So if you can observe this flame that we have been simulating, the blue flame is around twice as tall as the blue flame in this figure. So just by mere observation, we can say that the height of the blue flame that is predicted is reasonably close to the measured one, or to the experimental one. So let's resize this image. So there you have it, a direct comparison of the actual blue flame and the computed or simulated blue flame, which was post-processed using the ZST value. Hope you find this tutorial useful and get something out of it. Thank you. Bye-bye.